logarithm functions are related to exponential functions. You can't deal with exponential functions without dealing with logarithm. You can't deal with logarithm functions without dealing with exponential functions. Here's the exponential function that we studied in the last section. Basic exponential function, y equals 2 to the x. And the logarithm is just the reverse of that. If you swap the x and the y, now technically speaking in math this is called the inverse. Swapping the x and the y, this is the graph that we would get. We had a dot on 2 to the x at 0, 1. If we swap, that means 1, 0. We had a dot on the graph of 2 to the x at 2, 4. That means we've got a dot on the inverse at 4, 2. And so on. This is the graph of the inverse of 2 to the x. Now I'm going to go through the algebra of finding the inverse of that. And we'll go ahead and say this graph over here is the graph of the log base 2 of x. I know that sounds a little odd. Log base 2 of x, that's the inverse of 2 raised to the x. You just have to learn to deal with those words. Now here are the steps for finding the inverse of a function. Step 1, you want to change the f of x to a y. Step 2, you want to swap the x and the y. That's the key to inverses. And then step 3, solve for y. After you solve for y, that is the inverse. We typically write the inverse with the f and an exponent of -1. -1 means inverse, the inverse of f. So let's look at finding the inverse of 2 to the x. Here's the steps. Change the f of x to a y, swap the x and the y, and step 3, solve for y. Now this is where it gets peculiar, because over the course of the history of math there is no algebraic way of solving for y. You cannot do any of the techniques that we've learned from normal algebra to get that y by itself when it's up in the exponent. And there's one and only one way of doing that, as we will see. And so basically the way this has been handled is we say y is the exponent we put on 2 to get x. In other words, that's what this line up above it says. 2 to the y equals x says y is the exponent you put on the 2 to get the x. Now this exponent you put on 2 to get x is called log. That's all log really means. It's the exponent that you're using. Now I'm going to show you some of these to kind of get you used to the idea. Here's the log base 2 of 8. Now I don't expect you to be able to do all of these in your head, as I'll show you in class. You can use your calculator to do log base 2 of 8. However, understanding what the heck a logarithm means is a big deal. And this is what we read it as, and this is what our mind should think. Now you should be able to do this on your fingers. The exponent you put on 2 to get 8, and so that's the log base 2 of 8. How about the log base 3 of 81? Well, what's the exponent you put on 3 to get 81? Again, use your fingers. 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. Okay. Log base 5 of 25. What's the exponent you put on 5 to get 25? That's one of the easiest ones of the bunch. Log base 2 of 1 over 16. Again, you can't calculate this. In the past, people used tables of logarithms to do things like this. Big, long tables. Nowadays, we basically use calculators, as I'll show you in class. But understand that this means the exponent you put on 2 to get 1 over 16. Hopefully you're getting a grasp of what the log means. When you see log, your brain should immediately say the exponent. So anyway, log base 5 of 1, exponent you put on 5 to get 1, 0. What exponent do you put on 12 to get 1? That's 0 also. How about this? This is an interesting one. What exponent do you put on 2 to get 2 with an exponent of 5? Okay, you didn't pay attention. I just answered the question. What exponent do you put on 3 to get 3 with an exponent of 8? What exponent do you put on 7 to get 7 with an exponent of 99? Let me tell you something a little interesting about this. If you try typing this in your calculator, it will not work. However, we know, just from looking at it, it's going to be a 99. Now, all of those I just showed you aren't for you to be able to do those in your head. Again, I pointed this out sort of midway through. You need to understand the concept of a logarithm being an exponent. Nearly everything that you need to do with logarithms can be simplified if you just remember that. Since we know that the logarithm is the inverse of the exponential function, we can draw the inverse simply by switching this around. I showed you that in the opening slide. You can also type logs on your calculator, which I'll show you. On your calculator, there's a button that says log. There's also a button that says ln. On your calculator, you've got a key here that says log. Now that's an log base 10. It doesn't say that on the calculator, but that's what everybody understands it to be. You also have one just below that that says ln. Now that is an log base e. These are the two most popular bases that we ever deal with. In fact, the log base e is what we deal with the vast majority of the time. Rarely do we do log base 10s. Rarely do we do log base anything else. It's usually log base e. However, there's the keys on the calculator. Now, if I had to do these calculations, and again, you can take out your calculator and give these a try. The log base 10 of 1,000. You just push the log button, you push 1,000, and enter. Log base 5, log base 0.25, log negative 50. Notice this one, your calculator just says error. Now again, if you remember, when we looked at the graph, you don't have a graph for log that goes to the left of 0. You can't ever do the log of a negative number. But try it and see what your calculator says. It'll say error, meaning there's no such thing. Log base 1, 0. Your calculator can handle all of those fine. Here are the same numbers, but with the ln key. Again, give these a try on your calculator. And so this is what I was telling you. The log base 2 of 5 is not one that I can do on my fingers. So if I needed such a thing, if I have a TI-84 with the new operating system, it has a button on there for the log base 2 of 5. Otherwise, I've got to know how to do the calculation for log base 2 of 5. Here's the formula for that. I think it's on the formula sheet. If not, we'll get it on there. Or I can show you how to program it into your calculator. But all this is saying is to do the log base 2 of 5, you can do the ln of the 5 and the ln of the 2, then divide those answers. Now again, if you have a TI-84 with the new operating system, you can type that using the LOG base key, and I'll show you that in class. Here's what transformations look like with the ln function. This is the graph of ln of x. See, we got a dot at 1, 0. ln of x plus 5 is going to be the same graph, but shifted 5 units to the left. Here's the graph of ln of x plus 5 without the x plus 5 being in the parentheses. That means 5 units up. Here's the graph of ln of negative x. That means take the graph of ln of x and flip it horizontally. Here's the graph of negative ln of x. The graph of ln of x flipped vertically. Here's the graph of ln 3x. Now all of these you can type on your calculator, by the way. You might even give that a try. Compare it to what's on the screen here. ln of 3x I know is like the graph of ln of x, but the 3 tells me something is happening horizontally. It's a big number, so that's going to make it smaller. So it squeezes it in. The dot that was at 1 is now squeezed in closer to the y-axis. Here's the graph of 3 times ln of x. That's the same graph, but stretched vertically. The dot stays the same, and the other lines are going to get farther apart. Now, this is kind of the key to dealing with logs and exponentials. That's why you see a bright blue screen. Here is an exponential equation, b to the a power equals c. Now look, to change exponentials to logarithms, we do 3 simple steps, but they need to be done in this order. Number 1, the base. Over here on the left, the base is the letter B. On the right, LOG, the base goes down the bottom of the G. On the left, we know from what we looked at earlier, a logarithm is an exponent. On the left, where do you see the exponent? On the right, follow along. Logarithm is, to the right of that equals needs to be the exponent. There's the A. Now, the process of elimination, if the B goes down at the bottom of the G and the A goes on the other side of the equals, where does the C have to go? It has to go out to the side of the LOG. You need to be able to transform an exponential equation into a logarithmic one and vice versa.